Hello everybody, this is Ryan and I'm here for a video. This time we're going to talk a little bit about properties of logarithms. So let's get started with this. Here's our first slide. So if you have log base a of 1, so the way that's read, just so you understand, this is read log base, let's not put that minus in there, that'd be a confusing piece. Let's just do it like this. Let's do log base a of 1. That's how that's read. And this next one is read log base a of a. So log base a of 1 is equal to 0, and the natural log of 1 is equal to 0. If I have log base a of a, log base a of a is equal to 1, and ln of e is equal to 1. So the ln and e are inverses. Okay, so let's do a few more. Let's continue. So if I have a base raised to a log, so if I have a to the power log base a of m, that's equal to m. Because what happens is this actually just cancels off, and you're left with just the 7x. Log base a of r equals r, so log base 5 of 5. So as long as these pieces here are the same, it's just going to be equal to your exponent, 2t. Now you can add logs, you can divide logs. So if I have log base a of m times n, that's equal to log of base a of m plus log base a of n. So if I have log base 5 of 3x, that's equal to log base 5 of 3 plus log base 5 of x. That'll be pretty useful for you. That's a good one to remember. And just like if I have the log of a division problem, that's equal to log base a of m minus log base a of n. And another one that's going to be useful is this one down here. If I have log base a of m to the r power, that r can be moved out to the front. So that becomes r base a of m. That's also another pretty useful one. So let's use these rules to rewrite some of these logarithms. So if I have log base 6 of xy squared, now that is a multiplication problem, so that means addition. So when I have log of a product, you're going to split into addition. So that's the same as log base 6 of x plus log base 6 of y squared. Now, there's an additional rule here. You can take this squared and move it to the front. So that ends up being log base 6 of x plus 2 log base 6 of y. Now this one here is already broke up, but it's subtraction. So in this case, subtraction means you can combine them into logs using division. So the first thing you got to do is you got to remember that the 2 and the 7 in front of the logs, those actually move to exponents. That's the first step. They moved up here. And then you combine the logs together using a division problem. Now another useful tool for you is a change of base formula. That's actually a really neat way to find, to use your calculator to find logarithms of things other than base 10, because your calculator will only do base 10. So on your calculator you have this log button. That's actually the same as log base 10 of x. And you actually have an ln button. That's actually the same as log base e of x. So your calculator will do base 10 and base e. But if you want to do something like log base, you want to find the logarithm of 2, base 2 of 3, you have to use a change of base formula. And you can rewrite it like that. So here's an example. Log base 6 of 11 can be rewritten as log base 6 of 11 equals natural log of 11 over natural log of 6. Or it can be written as the log of 11 over the log of 6. It doesn't matter which way you do it. So I hope this video helped you. If you have questions, please